Good morning to everyone. My name is Jayashree. Today I am going to discuss about arithmetic coding in digital image processing. So here arithmetic coding is one of the lossless coding technique. Means here whatever be the input data you are transmitting over the channel, the same data will be retrieved at the output terminal without any loss of the data. So here this arithmetic coding operation, it will performs arithmetic operations on block of data. As we compare with Huffman coding, here the Huffman coding, for each bit we have to convert it into binary equivalent bit, but here arithmetic coding performs arithmetic operations on block of data based on the probabilities of the next character. So that here using this arithmetic coding, it is possible to encode characters with a fractional number of bits, thus approaching the theoretical optimum. So here if we compare with Huffman coding, arithmetic coding performs very well for sequences with low entropy, where Huffman code lose their efficiency. So here we can calculate arithmetic coding, encoding and decoding operation by using one example. So here the example is a source emits four symbols A, B, C, D with probabilities of 0.4, 0.2, 0.1 and 0.3 respectively. So here using these symbols with their probabilities, we have to construct a word DAD, D-A-D, DAD. So this DAD symbol we have to encode at the transmitter side and we have to decode at the receiver side. To perform this encoding operation is, first of all, write down what are the symbols you are having. A, B, C, D. These are the four symbols. And the respective probabilities given as already given as a 0.4, 0.2, 0.1 and 0.3. Here you have to write the subrange. Means here you have to write the cumulative probability distribution. That is from 0.0 to 0.4 you are having A as a number bit, and from 0.24 to 0.6 you are having B as a bit. Means here the difference between 0.6 and 0.4 is 0.2. Similarly here next probability is 0.1. So 0.6, the continuous one, 0.6 to 0.7 is C bit, and then continuous is 0.7 to 1.0 is a D bit. So here you can check that the total probability, it should be from 0 to 1 only. It should not exceed 1 because of the probability theorems. Here we have this probability range should be 0.0 to 1.0. So here first of all, what is your first step is, here draw a line where you have to divide 0 to 1 as a interval from 0.0 to 0.4 as a bit, and 0.4 to 0.6 is a B bit, 0.6 to 0.7 as a C bit, and 0.7 to 1 as a D bit. And then in the next step, encoding step, here the word we are to going is a DAD as a word we are encoding. So here the first letter is a D. So what is the interval of D? It is from 0.7 to 1. So here first of all I have constructed a line where 0.7 to 1, it is a interval of D, because here you are first of all you are encoding D as a symbol. So here after choosing what is the interval for D, that is from 0.7 to 1, here this same interval once again you have to divide as a B, C, D as a sub-intervals. Sub-interval, here we are having two equations. So to divide the 0.7 to 1 in interval as a sub-intervals of A and B, A, B, C and D, here we are having two equations. First equation is a low. Low is equal to low plus range into low underscore range, and for high interval, low plus range into high underscore range. So here what is the range? Here first of all, as we constructed just now, we have taken that interval as a 0.7 to 1. So the difference between 0.7 to 1, that is nothing but 1 minus 0.7 is 0.3. This is the range. and here low is nothing but here for this subinterval 0.7 to 1, the low range indicates 0.7. So here in our equation low, this value is for every time 0.7 0.7, and then low range high range. Suppose here we are going to divide the subinterval as a for a. First of all, we are choosing as a. For a, we are having low value as a 0 and high range as a 0.4. Similarly for b, low range value as a 0.4 and high range as a 0.6. Similarly for c, low range as a 0.6 and high range as a 0.7. So in this way, totally divide your 0.7 subinterval 0.7 to 1 as a different subintervals for a, b, c and d. So here first of all we have to construct this sub range for the symbol a. So write down what is the calculate what is the range, that is a 1 minus 0.7 0.3. So here first of all these equations are calculating the sub ranges for a bit. So 0.7, as I said, 0.7 is the low and range is your 0.3, and low range for a you are having 0.0 to 0.4 as a range. So here 0.0 is your low range. So calculate low value. So low is 0.7 you got. Then similarly calculate high. What is a high interval for the next bit? That is a low 0.7, range is a 0.3 value, and high range for a value is a 0.4. So the high interval for a is a 0.82. Means here in your the subinterval 0.7 to 0.82, it represents a bit. Similarly for b interval, for b symbol, low is equal to low, it is your equation, and for b you are having the probability subrange as a 0.4 to 0.6. So here 0.4 to 0.6. Here 0 point indicates low underscore range and 0.6 indicates high underscore range. So that here after substituting the values, 0.7 is as usually low value and range is 0.3, and low range value is 0.4 for B symbol. So after calculating you will be getting 0.82. Similarly for high interval, here 0.7 is your low value plus range as usually 0.3 into high range. High range is nothing but your high interval of the B. So here after calculating this value you will be getting high interval as a 0.88. So these steps is to calculate the subintervals for B. Here 0.82 is your low low interval, and then you got 0.88. So 0.82 is your low interval and then high interval as a 0.88. So this interval indicates as a B bit. Similarly for C bit, to transmit C bit you have to calculate, you have to follow the same procedure. 0.7 for C bit you are having the probability subinterval size is 0.6 to 0.7. So 0.6 is your low range and 0.7 is your high range. So here substitute all the values into your equations, low and high equations. Then you will be getting what is the low interval and high interval for the bit C. So here you got this low interval as a 0.88 and high as a 0.91. So 0.88 is your low one and 0.91 is your high interval for the bit C. Then obviously the remaining bit is for D. So here first of all, to encode the D data, here I have taken the D intervals, then subdivided the D interval as once again A, B, C, D bit using low and high equations. So first D letter is encoded, then you have to encode A letter. So the A letter intervals are from 0.7 to 0.82. Here you should not consider 0 to 0.4. Here the subinterval of D only you have to consider, that is a 0.7 to 0.82. So this is your 0.7 to 0.82. So here using the same procedure for the low range, low equation, low plus range into low range, high equal to low plus range into low range. So using the same equations, you have to subdivide the total 0.7 to 1 interval as a 0.7 to 0.82, because the A bit you are transmitting. So this interval once again you have to subdivide as a B, C, D. So here the range value is nothing but here 0.7 to 0.82, only this interval you are considering. So 0.82 minus 0.7, it gives your range value. So here 0.82 minus 0.7, it is your 0.12. So first of all you are transmitting the A bit, so that here for this low range is here 0.12 is your value, and low range is low value is 0.7, and here you are obviously you are transmitting A bit. For A bit your probabilities are from 0 to 0.4, so 0 to 0.4. So using these A values, calculate what is the high interval and low interval. And similarly for B, the probabilities are from 0.4 to 0.6, so low range and high range. So calculate what is the probability intervals for B. Similarly for C, you have to calculate. So here in the last, here that 0.7 to 0.82 for transmitting A bit, this is the interval we have considered. So after calculating low and high range intervals for A, B, C, D values, here you will be getting 0.7 to 0.748 is your interval for A. Then 782.772 is the interval for B bit, and 0.772 to 0.784 is the interval for C bit, and 0.784 to 0.82 is the interval for D bit. So we have encoded D A as a next bit. So after A, in your letter, in your word, this is your DAD DAD. So we have encoded A bit, D, and we have encoded A bit, then D bit. So here after getting this second interval, subintervals, here your D bit, it ranges from 0.784 to 0.82. So this is subinterval, once again you have to consider, but here there is no need to transmit next word, next letter, so that we can say that this is the D is the interval to transmit the last D bit in the word DAD DAD. Suppose if you want to transmit DADA, DA is a DADA. So here once again using this D interval, 0.784 to 0.82, once again write low equation. Low is equal to low plus range into low underscore range, and similarly high equal to low plus range into high range. So here the range value is nothing but difference between 0.784 minus 0.82. This is your range value. And here low value, for this interval low value is 0.784. So low value will be 0.784, and low range high range value, it depends on the ABCD bits. For A bit 0.0 to 0.04, and for B bit 0.4 to 0.6, and for C bit 0.7 to 0.7, and for D bit 0.7 to 1. So in this way low and high range values you consider, and once again you divide your interval as a ABCD bit if you want to send DADA as a bit. Otherwise D is my last bit, so I am stopping this D as a last bit. So after dividing the total intervals as a subintervals, here we have to send one tag value. So tag value is nothing but midpoint of the final interval. So here what is your final interval? After transmitting DAD DAD, this is my final interval. So midpoint is nothing but average of these two numbers, 0.82 plus 0.784 divided by 2, that gives your tag value. So this tag value is encoded for the transmission. So after encoding, at the receiver side you have to decode the same tag value, the same data. So here in this decoding procedure, here already we know what are the subintervals for the given data. So that is a 0.0 to 0.4 is a and 0.4 to 0.6 is a B, 0.6 to 0.7 as a C, and 0.7 to 1 as a D. It is we already know. So here the tag value after transmitting the data, the tag value what we got 0.802. So this 0.802 it lies in between 0.7 to 1.0. So what is the bit resides within this interval, that is a D bit. So here first of all I have decoded D as the data. So to decode the next data, here the next data within using this interval, here I have to calculate the next data, that is a tag minus low divided by range. So here tag, what is the tag we got, that is a 0.80 as the tag we got. So here low, the interval here after decoding D letter, the interval what I got 0.7 to 1.0 as the interval. So within this interval the low value is a 0.7. So low value I have taken it as a 0.7. So after that the range is nothing but the difference between 1 and 0.7. So 1 minus 0.7, that is a 0.3. So substitute the range value. So after this I got one more new tag value, that is a 0.34. So 0.34 where it is here in here a given interval 0 and 0.4. So within this you got 0.3 as a value, means here the next bit decoded bit is A, because here the 0.3 it lies in between 0 and 0.4. So here I have decoded the next value as a symbol as a. Then after decoding this A symbol, here once again consider the same equation, tag minus low divided by range. So now the low value is nothing but depending upon the new intervals 0.0 to 0.4 is the new value, because here I got a 0.34 as a next tag value. So here the low value is 0 and the range is nothing but 0.4 minus 0.00. So here after calculating here I got 0.85. 0.85 once again that is within this range, that is a 0.7 to 1.0 is nothing but your D as a next letter. So here first of all using this tag we calculated the decoded value as a D, which lies in between 0.7 to 1.0. Using this tag value once again we have calculated the new tag value, which we got as a 0.34, that is in between the range as a 0 to 0.4. So A as the next letter, and then using this 0.34 value once again we have calculated new tag value, that is 0.85, which is also in between the range as a 0.7 to 1. So totally we have decoded the value as a DAD as a tag. Okay, so in this way we can encode and decode the data using arithmetic coding technique. So similarly here we are having one more problem, that is how to encode and decode the word India. Here I don't know any probabilities, nothing. I don't know any subintervals. So just I got the India as a word. So here this India you have to decode and encode using this arithmetic coding. So here how many letters you are having in India? 1, 2, 3, 4, 5. Total 5 letters. So here I is repeating for 2 times. So here probability of occurrence of I is 2 by 5. Favorable outcomes divided by total outcomes, that is a 2 by 5. And N it is appearing only for 1. So 1 by 5 is the probability. D it is appearing only for 1. That is a 1 by 5. And A also it is appearing only for 1. 1 by 5 is a probability. So here in the fractional case is 0.4, 0.2, 0.2, 0.2. So its respective cumulative probabilities is 0.4, 0.6 and 0.8, 1.0. You see here, you can check this probabilities is up to only one value, okay, because it ranges from 0 to 1. So here write down the symbols, then probability, then sub range. So repeat the same steps. Means here first of all take 0 to 1.0 and subdivide I and dA, and here you have to first transmit I as a data. So using the same low and high range equations, here subdivide the 0.00, see here 0.0, 0.4, 0.6, 0.8 and 1.0. It is a INDA. So here first you are transmitting I as a value. It is a from 0 to 0.4. So 0.4 to 0.4. So once again you divide this interval as a INDA using the equations. I is transmitted, then N. So this interval once again you divide into INDA. So in this way you have to subdivide all the intervals until you transmit the letter A. After transmitting the letter A, find out the tag value, that is the last interval average. It gives the tag value. So using the tag value you can encode the data, and using the tag value the same procedure what I have explained for that, you decode the data using the tag value. Okay, thank you.